facts, or ideas, what you consume influences who you become. On the Mind and Matter podcast, we learn together from the best scientists and thinkers alive today about how your mind-body reacts to what you feed it. Before starting Mind and Matter, I spent 10 years in academia doing scientific research. I got a PhD in neuroscience where I focused on neuroendocrinology and the neurobiology of behavior, and before that, I specialized in molecular, developmental, and evolutionary genetics. I use my scientific background to help parse and translate the information that guests share on the podcast. In addition to the podcast, I write long-form written content inspired by the show where I integrate what I've learned across episodes. I also have a free weekly newsletter where I provide you with upcoming guests, share links, and provide commentary on scientific studies and research that I'm reading, and more. Visit mindandmatter.substack.com to find all of my content.
Yeah, good to be here.
For those who are unacquainted, do you want to briefly just introduce yourself and tell us a little bit about your background?
Yeah, my name is John Speman. I'm originally from the UK. I was born near Manchester. I spent most of my career at the University of Aberdeen in Scotland. I had a life-changing event in 2011 in that I moved 9 months of the year to come and work in China. And so from that point onwards, I was in Beijing for about 10 years. And then during the pandemic, I shifted within China to Shenzhen, which is down at the bottom, just across the bay from Hong Kong. And I run a lab there. My sort of interest is in energy balance and obesity and other things like aging. Previously, I worked almost completely on mice, but in the last 5 years or so, I've flipped over to almost completely working on humans, although I do still have a smaller interest in mouse work.
And we're going to talk about some of the recent work that you've been doing, but it has to do with a field that's been out there for a while that gets a lot of attention, where there's a lot of studies, and that's nutrition epidemiology. So do you want to give people just a basic overview here? What is nutrition epidemiology, and what is this field sort of concerned with or trying to do in terms of the questions it seeks to address?
Yeah, so basically what it's trying to do is understand modern disease patterns like cancer risk or diabetes risk or obesity risk, and see whether previous nutritional exposures are predisposing for certain risks. So, for example, a finding from nutritional epidemiology would be consumption of processed and red meats leads to an increased risk of colorectal cancer. So that's the type of study that they do. So when, and these things come out almost daily at the moment, that there's something happens, in the literature, and then it's a big thing on media for 2 or 3 days. And there was one recently, for example, connecting coffee consumption with positive health outcomes. And I remember saying to my wife, oh, look, there's an article here suggesting that coffee has positive health benefits. And she said, yeah, just wait a week. There'll be another one coming along that says it's negative. Mm-hmm. So that's the real problem with these studies, is there's very little repeatability in them. And the reason for that is because of some sort of substantive issues with the way that the whole field is structured and the techniques that they use.
Yeah. So when we hear about this stuff in the news all the time, on media, on social channels, scientists discover that there's a link between X food and Y outcome. This thing that you eat all the time causes this cancer or that disease, or conversely, this thing that you eat all the time causes some benefit. And what you're saying is these studies are numerous. They come out all the time. It's a huge field, but very often they actually contradict each other. So one study will say coffee is good, the next will say coffee is bad, and so on and so forth.
Yeah, exactly. And so one thing to think about is why these studies so numerous. Why are there so many of them? And the reason principally is because one of the main techniques they use is pretty cheap to apply. And so it's very easy for places that don't have substantial research funding to do a study that's a nutritional epidemiology study because it's relatively easy to apply the core techniques that they use are not expensive to use. And so it's possible to go out and do a study for not much money. You know, you just need a student and a computer, and basically you could do it.
Okay, so the techniques are easy and inexpensive to do. So there's a lot of people doing them, even if they don't have big research budgets. Right. Let's talk about what those techniques actually are and how good we think they are. So what would be, just describe like a quintessential nutrition epidemiology study. What are they doing? How are they measuring things? And what does it look like?
Well, maybe I should just explain the techniques because there's 4 techniques, and you can't really say this is a quintessential nutritional epidemiology study because they differ in exactly what they do, and some of them cross-validate the techniques and things like that. So one of the core methods that they use is something called 24-hour recall. So 24-hour recall consists of somebody's in a study, they've consented to be in a study, or they've just randomly phoned up. And what somebody does is do an interview of that person's previous day. So if we were doing it now, I would sort of phone you up and say, hi, would you agree to answer some questions about your food intake? And then once you agreed, I would say, so just walk me through your day. You got up. What did you have for your breakfast? And so you might say, oh, well, I don't eat a big breakfast. I just had a piece of toast and a cup of coffee. And then I say, well, okay, what did you have for lunch? And you say, oh, well, wait, was it Thursday yesterday? Yeah, Thursday I normally go to. So, oh, I didn't go there yesterday, but I had this for my lunch. And then you say, did you have anything in the morning? And you conveniently forget that Snickers bar that you had mid-morning snack. And so it's just like walking you through your day and you reporting everything that you do.
Yeah. So if I forget something or I'm a little bit embarrassed about something I eat and that doesn't make it in there, there's kind of no way to really know that.
Yeah. So, I think Herman Ponzer summed up these surveys the best when he said, like, it's like asking people, how many times did you have impure thoughts about Brad Pitt? Everybody underestimates. So it's exactly this situation that people miss things out. And that may be deliberate because they don't want to reveal what they've been eating, or it may just be a memory lapse. You know, you just genuinely forgot. You know, maybe every few days you eat something, but you couldn't remember whether it was yesterday or not, so you didn't report it. So they tend to. It's pretty well established in the field that they tend to underestimate what the actual food intake is, and we can come.
People tend to say they ate less than they actually did.
Generally, there's very little over-reporting. So normally, and that's why it's been thought to be generally a memory issue that people just forget because you're not logging that information.
Right.
And so to kind of get over that, another technique was invented called the food intake diary. So this now is a technique where the person just has a small diary with them, and each day they write down what they ate. So you, instead of me phoning you up and say, what did you have for breakfast yesterday? You get up, you have a little diary, and you write down a cup of coffee and a piece of toast. And you write down everything through the day. So that's got some advantages because you're immediately on the spot, so you're less likely to forget things unless you're deliberately fabricating what you're putting into the diary. But the problem with that is that it's a lot more invasive, and you may change your behavior because of writing it down, so you might say, okay, oh, I'm going to have that cheesecake. Oh, well, I'm going to have to write it all down. I'll just not bother today. And so there's an indication that food diaries are also kind of biased a bit because they change the person's behavior. And then an extension of the food diary was not just to give the person a diary, but also give them a scale. And the reason for that is that both 24-hour recall and food diaries have a kind of portion size problem. So when I say, what did you have for breakfast? If you say a piece of toast, we've no idea how big that piece of toast is.
Yeah.
So, you could be eating an enormous piece of bread or a relatively small piece of bread, and it's not captured. And of course, that's quite important in terms of your actual exposure to, if bread was something that was being analyzed in a study for whether it causes cancer risk or something like that, then, exactly how much you ate is pretty important. So, giving people a balance to weigh the food before they eat it obviously overcomes that issue because you then write down not only a piece of toast, but you put a piece of toast weighed. Well, in the US, I guess it would be in ounces, but in the rest of the world, you would be writing it down in grams, so like 125 grams, 4 ounces.
Yeah. Okay, but the point is basically there's some subjectivity here. You might have a memory lapse, or these techniques might be prone to some level of not just inaccuracy, but systematic bias.
Yeah, right. And the thing is, if you're weighing your food, it's super accurate, but it's the burden on the person is so big that you get people changing their behavior because it's too much trouble to actually weigh everything, And so you say,
if I have to weigh everything I'm going to eat, it's a pain in the ass. Right. It's going to change my
exactly.
I'm not even going to want to do it. Yeah.
Yeah, and so then if you're not weighing everything, you have this portion size issue. How big's enough? How much is actually how much nutrients or whatever is in an apple, because apples vary enormously in their size, whatever. So the other issue is that these are all based on like one day, and the problem with like one day of recording is it may be an unusual day.
Right.
So if I catch you on a weekend, your food intake might be substantially different than what you eat during the week. And so to get over that kind of issue, there was another technique invented called the food frequency questionnaire. So the food frequency questionnaire it's also an interview type format, or the person has like a form that they fill in. And what they do is they detail, if you take a given food, you detail how frequently you eat it. And so I can give you an example of one of these if you let me share the screen here.
Okay, so let's look at it. And for those just listening, we'll try to describe it well so that you can imagine what we're looking at. But obviously, if you're on the video version, you can actually see this. But we'll see what people actually fill out here.
So let me see whether I can share that. It seems like that's not coming up for some reason. Just bear with me a second.
Yeah, no worries.
Okay. So I don't understand why that's not coming up. I guess you can maybe cut out some of this. Me filling it out. Okay. So I think you probably have that now.
All right, there we go.
So what you can see on the left there is a list of food. So basically it says, how often in the past 3 months did you eat the following? So this is already, if we're talking about memory issues over 24 hours, you can imagine that the memory issues over 3 months compounded. And then, you have these very broad categories, less than once a week, 1 to 3 times a week, 4 to 6 times a week, or more than daily. And people just put crosses in there. Okay, I eat beef 1 to 3 times a week. What's really interesting is what's done with that data. So in this form of a food frequency questionnaire, that data is converted into a daily frequency of intake. But it's ridiculous because, you take a speculative kind of, I eat it 1 to 3 times a week, okay, which is already very vague.
Yes.
And then that's translated, if you look on the beef line, 1 to 3 times a week becomes a daily frequency of 0.285.
Right. And there's assumptions baked into that. So you're taking a coarse-grained and subjective input of data, and then you're actually making it less accurate than it already is by doing these transformations that rely on you making assumptions.
And you get a number there that's like 3 decimal places.
Yeah, which is ridiculous.
So that's the kind of big issue with this kind of thing. Okay, I'll stop sharing there.
Yeah. And I think one thing to emphasize here for people is, if there's just random noise in a data set, whatever that data set might be, if it's truly just like random noise, you can just get a lot of samples, you can do a lot of averaging, and then that noise will become less of an issue. But if there's systematic bias and non-random noise in the data, it doesn't matter if you have a large sample set. It doesn't matter if you do multiple studies. If there's a systematic bias there, you're not going to be able to average that away.
Right. So the other issue is that, you take these numbers, like a piece of toast or beef 1 to 3 times a week, is what the portion size is. So there's a lot of extra kind of work to go from that number actually to a portion size to then judge what the exposure is. So you end up with a number that is pretty inaccurate.
Yeah.
And like you've said, that might not be an issue if you've got a big enough sample and it's just random kind of biases that are in there. But if there's any systematic bias in terms of what you omit or what you underestimate you're eating, that's always going to feed through as a problem. And so there are two. Sorry, go on.
Oh, I just wanted to ask you. So there's a lot of these studies out there, and as you said, they're cheap in one sense, that they're very easy to do. You don't need a particle accelerator to do a food frequency questionnaire analysis. What do the people? There's so many of these studies at big name universities like Harvard. They get a lot of attention, and there is a lot of funding that goes towards making this stuff possible. But if these food frequency questionnaires and the questions are as bad as you just showed us, as imprecise and subjective and subject to potential bias, what do the people in these fields make of their own methods? When I look at one of these papers, what it almost always says at the beginning is, we used food frequency questionnaires, blah, blah, blah. These are validated techniques. In what sense have these things been validated?
Yeah. So that's a really interesting kind of statement, and it's good that you point that out. So what has been done in the past is they've used like 2 techniques and applied them to the same people. So a classic example, since you brought up the Harvard people, the nurses study that's done by the Harvard Nutritional Epidemiology group is a classic case where they use food frequency questionnaires, but they've also done 4 24-hour recalls on the same population, or it may even have been diaries. And what they say is that when we compare those, the correlation coefficient between the 2 is somewhere between 0.4 and 0.7. And therefore, there's a trend for when somebody says something on the food frequency questionnaire, it's also there in the diaries, and therefore these are validated against each other. But I mean, it's not really a good validation because they're both somehow tainted by the same problems. So like 24-hour recall has got a big memory issue, and food frequency questionnaire has got a big memory issue. So if that memory issue is the same, you're going to end up with a correlation between the 2 just because people are forgetting the same stuff in both surveys.
Right.
So it's it looks great when it says they validated questionnaires, but the validation is not particularly great.
So when they say that we've validated things, that's what they mean. It's like we've used this noisy technique and this one, and they're correlated with each other. That does not mean, I just want to emphasize this for people up front, like obviously that does not mean they've actually measured directly what these people are eating and what the nutrition content is. They're not doing that at all.
Absolutely. And, I mean, it's you can't validate one poor technique with another poor technique. And it is surprising that there's any correlation at all, given how inaccurate they are. But an R value of 0.4 is really not very good.
No, that's not that strong. Yeah.
So it's barely there, and it's only significant because there's a big sample size. So I don't think that really gives us much confidence that the methods are particularly great. But I think there's another point that's worth just making, is that individual food intake is pretty variable on a day-to-day basis.
Yeah.
And so there have been attempts to try and measure that. So if you look at, for example, people who are brought into a residential setting where you can measure exactly what they eat, the variation from day to day is about 30%. And so even if you had a technique that was absolutely 100% accurate, it's inaccurate because you only measure one day. Okay, so you can be up to 30% out for what the person routinely eats just because of that day-to-day variation. And the way that shakes down is that if you want to improve that precision, if you want to, narrow that down, you have to do repeated days. And so it turns out, just the way that the maths works for the coefficients of variation, is that if you want to reduce the error from 30% to 5%, you need to do about 35 daily recalls. You want to get it down to 10%, it's about 15. So you'd have to do an awful lot of these daily recalls before you got to something that was a good estimate of what the people were eating. And that's if you've got a tool starting out that's 100% accurate. So even if these tools were 100% accurate, they're not applied frequently enough. So very, very often, these studies, they apply a 24-hour dietary recall once, and then 15 years later, they say, okay, this is the link between consumption of coffee and heart attacks.
Yeah. And there's layer upon layer of things we could talk about here. Like, obviously, even if you could measure everything accurately and we both ate 6 ounces of the same food, I might cook it differently than you. I might prepare it differently. It's not going to be the same matter going into my body. And so these studies are poorly done, in my opinion, and I think your opinion and others as well. And this has been known for quite a long time, but I guess what the study that we're going to come to from you is you guys kind of quantified exactly how bad and what kind of systematic biases are actually introduced by these techniques. Is that right?
Well, okay. So, I mean, I think we've got to go a little bit to the motivation of the study. So, I mean, the motivation of the study is not to make these things look bad. The motivation of the study is actually to provide a tool that people who are using these techniques can use to make the technique better. So this is a kind of a way of potentially improving what people do when they use these food frequency questionnaires, or particularly 24-hour dietary recall studies, that can just help screen the data to pull out things that are obviously ridiculous. So that's basically what we're trying to do. I'm not trying to diss these studies. I'm trying to help the people who do these studies to do something a little bit better.
Yeah, we can talk. We'll circle back to that question. We might have some differing views there, but let's walk people through what you actually did. Just to say it up front, I don't think people should be doing this work at all because I think it's that ridiculous. What did you do?
Okay, so let's go back to the 1990s. Okay, so in the 1990s, there was a kind of recognition that these studies they have a problem, and these all the things we've just spoke about have been known for 40 years. I mean, this is not anything new. So in the 1990s, people hit on this idea and they said, okay, one thing that people get from these studies is the daily energy intake.
Mm-hmm.
So if you're recording a group of foods that are being eaten, you can multiply those up by the energy content of those foods, and you can get an estimate of what the daily food intake is. Yeah? So we have another technique that we can estimate the daily food intake. And so the idea was, okay, let's use that other method to compare what the estimated food energy intake is to this other completely independent method. So this is a kind of validation, but not using another technique that depends on memory.
Yeah. So the extent to which these things match up or don't match up is going to tell you something about how accurate the one technique is.
Right. Exactly. So, and the technique that they used was actually to measure energy expenditure. A routinely used method is something called a basal metabolic rate measurement. And in that, somebody lies down, we measure the gas exchange from their breathing, and from that gas exchange, we can tell how much energy they're spending. But it's the energy expenditure of lying down when you've not eaten anything. And so the question is, how much greater is your actual daily energy expenditure compared to that low level? And a number that's kind of bandied around is about 1.6 times your basal metabolic rate. So a couple of scientists from Cambridge University in the UK said, well, okay, 1.6 is normal. We don't believe that anybody could actually be alive with a value less than 1.35. And so what they said was, if your food intake record is less than 1.35, then the predicted BMR for that person, then it's likely too low. Did that make sense?
Yes. I mean, yeah, but also, the word likely is doing a lot of work here.
Okay. So the big problem with that is that predicting the BMR has an error.
Yeah.
And that number 1.35 is completely arbitrary.
Mm-hmm.
So we don't, maybe it's not possible to live with less than 1.4, or maybe people can survive happily at 1.2. So it's a completely arbitrary decision where you set that cutoff.
Yeah.
And these numbers are not adequate. But that identifies a relatively large number. So this is these screening tools were one of the first ways that people started to realize, hey, these intake records are not particularly great because a lot of them are just implausible.
Yeah, they would give numbers that were very unlikely to be true. And it's hard to know these things.
In many cases, completely impossible to be true. So they're less than basal metabolic rate.
Yeah. Okay.
So nobody can survive with less than basal metabolic rate. So clearly, that intake is either a day when the person wasn't eating much and is therefore misrepresentative of their actual intake, or they lied, or they misremembered. Yeah. So that was a technique that was invented in the 1990s, and is still available today. And the paper that Goldberg and Black published has been cited more than 1,000 times and used in more than 1,000 studies. But there are probably 70,000 studies, so it's still not used very often. Yeah, lots of people know that technique's available and they don't use it.
Yes. I mean, just okay. I mean, one wonders why, but
Yeah.
I mean, yeah, there's no
It's
reason not
interesting.
to. To me, it's just like, okay, this is all just, this is not even a real field of study, in my opinion. But what did you guys do with this doubly labeled water experiments? What is that?
Yeah.
That's
Okay.
sort of your
So
wheelhouse.
okay. So do you want me to explain what the technique is, what the double labeled water technique is?
Yes, I think that's good because
Because there
most
might be
people,
people listening who are not so clear on that. They might
yeah,
have heard of the technique, but they're not sure how it works. So what the double labeled water technique does is you drink some water where the stable isotopes of hydrogen and oxygen have been enriched. And they're completely safe, they're stable, there's no radiation involved. You drink that water and it floods into your body, into the water in your body. And then over time, because you're constantly taking water in, either as a beverage or in food, and you're constantly losing water in your feces and urine and by evaporation, the enrichment of that heavy hydrogen gets slowly declining. It's a negative exponential curve that brings you back down to the background.
mm-hmm.
And of course, because an oxygen molecule is also in all the water molecules, it's washed out as well at the same rate. But it's also washed out by another process, which is breathing in oxygen and breathing out carbon dioxide. And so there's a divergence in the elimination of the two isotopes. And from that divergence, we can estimate the CO2 production, and that gives an estimate of the energy expenditure.
I see. So when we go about our day, we're drinking water, we're losing water, we're breathing in
Yeah.
air, we're breathing out air, and based on the rate that these isotopes go away because of the natural cycling of water and oxygen through our breathing and through our bodies, you guys can measure those things, and then we don't need to get into the details, but that measurement tells you something about the actual metabolic rate of that person.
Yeah. So the classical technique for measured metabolic rate is called calorimetry. And so we can work out how good this technique is by comparing it to calorimetry. The beauty of the method is you drink the water, you can go away for 14 days and just do your own thing. Forget
it's easy to do, non-invasive.
Yeah. So it's easy for the person to do. There's no burden at all, really, for the person. And we can collect urine samples, and from those urine samples, we characterize that water. If you compare the method to simultaneous indirect calorimetry, the accuracy is really good. So the accuracy is about 0.5%. It's great, but the precision isn't so great. So it's about 7%. So maybe I should explain accuracy and precision. So an individual measurement let's say I make a measurement and I'm 5% higher than my expenditure, my indirect calorimetry expenditure. You make a measurement and you're 5% below. Averaging those out, the accuracy is zero. There's zero error in the average across us two, but we're both 5% out. So if you take the average, removing the sign, the precision is 5%, but the accuracy is zero. So when we do that across a group of people, and it's now been validated in about 60 people, the average is less than 1% for accuracy, but the precision is about 7.5%. So when I make an individual measurement on somebody, we know it's got an error of around 7.5%.
Got it.
So because that technique gives you an estimate of the daily energy expenditure without us having to make any kind of guess of what this factor is above BMR, you could use that to predict somebody's energy expenditure. So you could say, okay, let's measure a bunch of people, get a predictive equation, and then we can apply that to all the people who do the survey. Yeah? And then you could see whether they were under or above what the prediction was. And that idea was actually in a paper around about 2000 out of Susan Roberts' lab in Boston. Vinken et al. is the paper, and they proposed this approach But the problem was they had relatively few measurements by doubly labeled water. The technique's relatively expensive, and they only had 80 measurements, and they actually didn't have any measurements of adult males in the sample. They had some old males, adult males. They didn't have any males between 18 and 60. They had some older males, but they had a good population of females. So the problem was the equation's not particularly great in that situation, but the idea is good. And so what we've done is about, maybe nearly 10 years ago now, the main users of the doubly labeled water technique came together and created a database of values. And that database, actually, I just updated it yesterday. It's currently got nearly 13,000 values in it. But when we did the paper that I'm just going to tell you about, it only had about 6,500, something like that. Mm-hmm. So what we did was we took a sample of those, I think 6,500. We took about 5,900 of them. And we used those to build the best model we could possibly make to predict somebody's energy expenditure. Okay? And then we used that to predict the 600 that we didn't put in the model. Mm-hmm. Okay, so it's a kind of cross-validation approach. And what we showed is that the accuracy, again, was really good, and the precision's about 12%, something mm-hmm. like that. So if you think about, making an actual measurement has a precision of about 7.5%, 12% for a prediction equation is actually pretty good. Mm-hmm. So what that means is anybody in a survey, you could take a bunch of information about that person, like their height, weight, race, sex, where they live. If you have all that information, you can then get a prediction of their expenditure. And what's cool is when you make that prediction from a regression equation, you can set confidence limits on the prediction. So you can say, I predict your expenditure is 2,500 calories per day. And given the errors that we know are in the method, we have 95% confidence that the actual number is between 1,900 and 2,900. Mm-hmm. Okay. So that's a pretty big range, but that gives us a hard lower limit that we could say, if your record from a dietary survey is below that lower limit, the chance that it's real is only 5%. So we can put some hard numbers on it instead of like the Goldberg cutoff, where we've no idea what the chance of being below mm-hmm. 1.35 is.
You're saying this is a way to filter that data that has non-arbitrary cutoffs. So it's better, it's more objective, but the if we think of a filter like a food colander, if we're trying to filter water, we want the holes between the metal to be as small as possible. So we've gone from having giant gaping holes to somewhat smaller holes.
Yeah, I mean, I guess that's one way of looking. I hadn't thought of that analogy, but I guess that's one way of explaining it. I think what we want to do is we want to retain the survey data that are potentially okay. And this is one way to do it. So mm-hmm. there's been a kind of couple of kickbacks on that. So basically, one common kickback is, well, hey, we're not looking at energy, so this doesn't apply to us. We're interested in intake of protein, mm-hmm. So, mm-hmm. We've never said anything about energy at all. So, we can ignore what you're doing. But, that's not the point. The point is that if you're below that lower cutoff, your record of how much that person's eaten, which includes all the things you're interested in measuring, is implausibly low. Mm-hmm. And so it's, you're missing something. It's just telling you that you need to be very careful with that data because, that record misses something out of the intake.
Mm-hmm.
Yeah. So the other thing people say is, well, okay, we're not interested in the absolute intake. We're only interested in like quartiles of intake. Who's in the top quartile, who's in the second, third, fourth. And the food frequency questionnaires can tell us that. It can tell us who's the high consumers and the low consumers.
Mm-hmm.
But that's actually a kind of fallacy, because the whole thing about these exposures is the absolute exposure. So if I said, okay, I've got a population here and the top quartile smoke 2 packs of cigarettes a day,
right,
and the bottom quartile smoke only half a pack of cigarettes a day, the link that you would build there between that exposure and cancer risk is completely different if you had a population that was going from 0 to half a pack a day.
Right.
So it's the absolute numbers that are important. And there's a famous example just come out recently looking at ApoB against, progression of plaque.
Yeah.
And there's no correlation. But the problem is it's over a very narrow range. So if you have a narrow range in your population, you're not going to pick up the effects of these exposures. So just saying, okay, we're only looking at quintiles, that's, we can ignore what you're suggesting.
Yeah. No, I think the smoking analogy is good, and people will get that intuitively. Like, if I do a study and I'm looking at, people who smoke 2 packs a day compared to people who smoke 1 pack a day, I'm going to get very different results than if as John said, you look at the full range of what's out there. People who smoke not at all, who smoke just socially, all the way up to 2 to 3 packs a day. And so all of those details matter. And obviously, when we're talking about the effect of food on health, the absolute quantitative amount of anything that someone eats is going to be relevant enough of interest.
It's the most important thing.
Yeah.
So then the other thing that people say is, well, okay, although my food intake record is implausibly low, it is representative of what the person actually ate. So in other words, there's no bias in the missing energy if they're eating, 20% of their calories from meat. In what they reported, maybe they ate 20% calories of meat in the bit they didn't report.
Right.
And therefore it doesn't matter.
Yeah. So the argument is that basically the data, although inaccurate in that sense, is still going to be directionally showing the patterns that are there.
So if that was the case, you would expect there to be no relationship between the intake of a given component in the diet and the plausibility of the estimate.
Yeah.
And what we show in our paper is actually that's not true. So there's a systematic bias introduced in relationship to how much you underreport. And so that doesn't rescue you by saying, okay, it's low, but it's representative. It's just not true.
Mm-hmm, mm-hmm. Yeah. And so walk us through some of the relationships that you saw in this paper with respect to things like BMI, age, sex, and I think elevation was even in there.
Yeah. So what we did was we applied the equation to 2 big surveys. So the NHANES survey in the US and the National Dietary and Nutrition Survey in the UK.
And these surveys, these are big surveys they're basically databases that people can have mined to publish stuff over the years.
There are literally hundreds of studies that use those databases. And that's another kind of good thing, bad thing. That data is paid to be collected by the respective governments of the US and the UK. And because it's government collected data, they make it publicly available. So you can do an even cheaper study if you just take that data and you mine that data to look for associations between intake of different things and outcomes, which are also published for the same population.
Yeah.
So, you get an even cheaper output. And there are people who spend their lives just mining that data and publishing papers on, vitamin D causes this or whatever.
Mm-hmm.
So what we did was we looked at things like, if we call it like the extent of underreporting, the discrepancy between the measurement with the prediction from doubly labeled water and the measurement from the dietary survey. If there's no kind of underreporting, you would expect that difference not to change with things like BMI or sex or things like that.
Yeah.
And so the biggest thing that falls out of that is that people who are heavier, who are higher BMI, underreport much more. And that has some major consequences. If you're saying something causes obesity, and okay, we can get into whether BMI is a good measurement of obesity or not, but
basically you're saying the level of bias is different for obese and non-obese people.
Yeah. So, and it gets progressively worse the higher your BMI is. So the consequence of that is if you then try and link an exposure to somebody's BMI, you're systematically biasing what you're measuring. So then you can say, let's take an example. This is not from the data, but let's just take an example. If people underreported their intake of fruit, for example, as they got bigger, you would make an association between healthfulness of eating fruit and it protecting you from obesity, but it wouldn't be true.
Right,
all it is that people who are larger tend to underreport eating fruit.
Yeah. You're basically you're basically saying that your results show that these sort of statistical mirages are bound to show up in data like this.
Yeah, right, because of that bias. And so what we did was we showed was that if you screen the data using the tool that we produced, you can massively reduce those biases. So by only including data that are plausible, then that bias with the BMI it's not completely removed, but it's massively attenuated. And so the consequence of that is that what we've provided to the field is a tool that they can use to improve the survey work. And it's relatively cheap to do because all you're doing is some calculations and you can do it retrospectively. So the procedure that I've kind of suggested in the paper, or we've suggested, is what people should do is if they do like some survey work, they should analyze it the way that they're doing it at the moment, but then they should reanalyze it, screening out the implausible values. And if the story stays the same, then fine. It's looking good. You're not influenced by these biases. But if the story changes, that something's no longer significant, then that's a red flag. You shouldn't be then putting that out in the literature and saying exposure to X is causing you to have an increased risk of cancer or whatever.
But when you find those associations that are significant, that chocolate causes you to live forever or whatever the result is, and Newsweek is calling you to talk about it and you get to publish it in a paper and, maybe you get promoted at the whatever school of nutrition epidemiology. If they apply your technique and those results become less significant, do you think people are going to do this very often?
Well, I mean, that's one potential reason why they don't use the Goldberg.
Right. It's even easier to apply.
Yeah. So, I mean, all I can say is that, it will now be possible very cheaply for people to apply this technique and retrospectively check what you've done.
So other people could check the work that goes out there that makes claims. Yes.
Yeah. So you might not want to do it yourself because, it's nice to have all this fame and glory for the chocolate result, but somebody's coming along and they're going to check it.
Yeah. Okay. Yeah.
So you may as well check it yourself first.
Yeah.
And then, there's less issue.
Yeah. And what's nice about some of this in a sense is, because some of these databases are, accessible, because obviously anyone can go look up the published work that goes out there, because your methods are going to be accessible here. And because, of the internet and the power of computers that defines the modern age, there's a
Right.
lot of motivated people out there who might go and check some of the work that has been published.
Yeah, absolutely. And so one thing we've been talking about, and I've actually approached another big database in the UK is UK Biobank.
Mm-hmm.
They have 500,000 people that are characterized for all sorts of things. But one thing they have is 24-hour dietary recall in there. We've approached them to say we could apply our technique and just put a red flag against any number that we think is implausible.
And that's just
So
part of the
that would,
database that people can
it would
filter
be
out.
in the database then, and they've been positive about that as a potential way forward. So we have to apply to get access to the database to be able to do that. But so far they've been quite positive. And I'm also in contact with people at NDNS who we're going to work with in a different context anyway, to potentially do the same. So it gives people up front an indication of which data might be worth including and which data might not be worth including. And then it's up to the person what they do. We're not censoring the data. We're just giving people more information.
Mm-hmm, mm-hmm. Yeah, yeah. So given what you found and sort of given the history of this field and the flaws in some of its techniques that we went over, as a field, nutrition epidemiology, what do you think the results that are out there actually tell us, if anything? Are there certain types of results that you think are believable or valid, or should we kind of ignore it?
So I personally don't take any notice of these papers. I don't think there's any good prognostic value in them for you changing your behavior. So I don't ever look at one of these studies and think I should stop eating blue cheese or whatever. I just don't think the data is reliable enough to be a tool for behavior change at the moment.
Mm-hmm.
So that's where I am on it. Everybody's got to make their own decision, but my guess is most people do not change their behavior as a result of these surveys. So the practical consequences of them are minimal. And the reason behind that, I think, is because they are so variable. So you get so many varied results that people just say, well, okay, look, I gave up coffee last week. Now I'm being told it's really good for me. What do I do? And so people just switch off at the end of the day and they don't do it.
Yeah, yeah, yeah. Because this stuff is out there. There's so much of it, and it goes in every direction that it can just be confusing and overwhelming, but also like people can, when you get contradictory results, people can selectively pay attention to one or the other depending on what they would like to be true.
Right. So that's why I like the coffee is healthy result. Because I have an intrinsic bias towards drinking coffee, but I think the way the field is evolving is actually quite interesting because these techniques are they're cheap, but they're old. They've been around for 50, 70 years. And there's no real big development of them. And I think as we move forward, what's happening is people are realizing that there are new technologies coming that we could potentially use. And so there's been a big shift towards people using photo diaries. So basically, you just use your smartphone and take a picture of everything that you eat.
Mm-hmm, mm-hmm.
And in theory, that should give you a more accurate result. It depends, of course, on people photographing everything, which is, potentially an issue. And also, you have to identify what's in the photo. And there has been some kind of development of AI techniques to identify what the foods are. So you just take a picture and then you give the picture to an AI and it says, okay, well, that looks like some fries and a burger and whatever. So, there are some potential. We've used that as a technique to look at food intake of people with extremely low BMI and shown that they eat quite a bit less food than people with normal BMI. It's not completely accurate because building an estimate of the weight of the food from a 2D picture is quite hard. But other people are doing this as well. But one thing we're doing is collaborating with a company that changes your phone into a 3D scanner. So it uses the LiDAR function in an iPhone. So LiDAR is a near-infrared laser that your phone produces to work the autofocus. Okay, so when you autofocus on somebody's face, what's happening is it's shooting out an infrared laser and it bounces off the person and then focuses at that distance. So that's how autofocus works. But you can use that LiDAR to measure the distance between the phone and any point, and you can produce a very detailed picture of a plate of food, and you can estimate the absolute volumes of those bits of food, and then use an AI to identify what the food items
I see.
are.
So technology is getting to a place where maybe in the not so distant future, I could sit down to dinner, I can point my phone at my plate, I can then eat my dinner and finish it, point my phone back at the plate, and we can calculate with some accuracy what I consumed.
So with some accuracy is the way to say it. At the moment, it's not fantastic, but it's probably better than you saying, I had a portion of fries. Yeah. So
I think I remember eating 2 portions last Wednesday.
Right. Okay. Yeah. So exactly. If you have that picture, I mean, it's a bit more burdensome, but it's less burdensome than having to weigh all the food items.
Yeah. And I mean, we can be certain that, I don't know if it's tomorrow or next year or 10 years from now, but technology moves pretty quickly and the techniques will probably get pretty impressive at some point.
Yeah. I mean, I've been amazed at how good these 3D images are, because when you first look at them, they just look like a plate, but then you can rotate them and you can look at the plate from different angles, and it's a pretty good representation of what's on there. So I think that will move that side of the field forward. But I think, what we probably ultimately will move to is also not trying to better quantify what's going in, but quantify what comes out.
Yes.
So
yes.
Everything that you eat appears at some point as feces and urine. And so there are techniques out there. For example, if we look at urine, we can already look at the nitrogen 15 signal in the urea of the urine and make an estimate of how much meat you eat.
Mm-hmm, mm-hmm. Yeah, and I guess tied to that is another complication in this whole sort of stack of things that we've talked about is even if you had perfect measurements of what someone consumes, and even if you had perfect measurements of the content of all that food, you still don't know how much their body's actually absorbing of all of the different nutrients. Someone could have gut issues that prevent them from absorbing something that someone else can absorb, and all of that stuff.
Yeah, so that is another completely unknown. So it's generally assumed there are these Atwater factors, and you can work out roughly what's being absorbed of the different foods, but with no real degree of accuracy. So we've been measuring food intake and fecal production in people, and there is some individual variability in there. So some people are particularly good at digesting food, and other people are less good. And we're trying to, work out what the correlates of that are. But that's another complication on top that we didn't discuss at all, and is generally just completely ignored in the field.
Yeah. But it sounds like you guys are working on stuff where you're measuring, you're focused on the inputs and the outputs of the human body, and you're actually trying to measure these things better.
This is never going to be survey work, obviously, but it does give us more kind of things to potentially think about. So taking a spot urine of a person is not a very onerous thing to do, and so you could survey large numbers of people with that technique. And if you can get information from stable isotopes in the urine, or to give an indicator of what they're eating, then you can cross-check that against the survey So it just gives us another tool to see how good the surveys are. And there's some of that already been done, so there is some biomarker validation of survey work.
And so, John, let me just ask you, as from your position as a researcher and based on everything that we talked about and what you've done, what would sort of be your general advice or takeaways that you would leave the average person with in terms of how much they should or shouldn't pay attention to the headlines that are out there all the time around, different foods or different nutrients causing this or that outcome?
I think it's extremely difficult because obviously most people are not going to go and read the papers. So it's very difficult to give advice, because to really judge how good something is, you need to actually know what the techniques are that they applied. And, then, you can then make a judgment as to whether, is this likely to be true or not. There are some great studies out there where people have done randomized controlled trials where they've given people different foods. I mean, there was one recently looking at vitamin D, putting Deirdre Tobias's group. So these are great studies, and these really give you the information that you need to tell you whether you want to change your diet or not. Those are the ones to look for. So the things to look at are, does it say in the title, randomized controlled trial? If it says that in the title, it's a good study and you should probably pay attention to it. If it looks like it's based on survey work, I personally don't pay any attention to the outcomes of those studies, because I don't think they're accurate enough to do things. And so the red flags for me is, how long was it between the survey and the outcome? And how many times did they assess the diet? Can you really tell a link between cancer risk 15 years after one day of intake? I don't think you can.
I don't think so, yeah.
It doesn't make any sense. And so changing your behavior on the basis of that one day of intake 15 years ago, it's crazy. I don't think it's worth doing that.
All right. Well, John Speakman, thank you very much for your time and for doing this you're in China right now?
Yeah, I'm just about to go off to work. I guess you're just about to go off to bed.
Yeah. So, well, I have to eat dinner. Yeah.
So if people are interested, maybe I could just say where the paper is. So if people are doing survey work and they want to explore it. So it was published in Nature Food, and it's got a title something like Predictive Tool for Screening Survey Work or something like that, based on 6,500 doubly labeled water measurements.
Yeah, predictive equation derived from about 6,500 doubly labeled water measurements enables the detection of erroneous self-reported energy intake. There it is. Great.
And, I hope people will use it. I think our goal is to help people in this field to do better work. It's not to diss the methods. It's to try and improve the methods to get better science.
All right, Dr. John Speakman, thank you very much for your time.
Thank you.
Visit mindandmatter.substack.com to find all of my content.